Hello, my name is Charles Romine. This is my glider project report for AE1601. Let's get into it. To start, we were tasked with making a glider that would fly 20 feet that fit inside of a 16 by 16 square. That was kind of with the balsa wood we were given. That was the project description. And then these were those requirements. So the first one is 16 by 16 inch square, so it had to fit inside of that box. In order to be successful, it had to fit in the box. A minimum flight of 20 feet. So it had to go at least 20 feet, like straight from where you threw it, not 20 feet way to the left or right. That was important. Only like straight on distance counted. And then it needed to be made mostly of the balsa wood we were given. We were allowed to add parts and things as we needed, but we didn't need to like 3D print entire gliders basically. So next we're going to talk about some like design processes that I went through. This is a picture of my first iteration, which I made out of paper with a weight inside of that paper tube. The first thing I did was my first version of this, the tail wing was not angled, which was a mistake. So I changed that and then had an angled one on my final design as well to kind of counteract some of that lift generated by the wing, by the main wing, give kind of a moment to the back of it to help kind of balance out the glider. Another um, design thing that I really looked at was the shape I wanted my wings to be. I eventually decided on a tapered wing because I felt that it gave kind of the best ability to kind of cut through the air and was a little more aerodynamically shaped than a rectangular wing, but um, avoided a lot of the technical difficulties of like a dihedral. I didn't think a dihedral was going to be a good idea because my balsa wood, at least, I cracked my wing at least twice. And I felt that if with a dihedral and more dimensions and things, just was not going to be a good thing for the sort of structural integrity of the glider and it being able to fly multiple times through testing and then also on the day of flights, especially if I'd made it through more than the first round. So the next thing I kind of looked at, this glider in front of you banked like crazy when I threw it if I didn't throw it really, really level. So on my final design, I added a vertical stabilizer. This was just good all around because it helped my glider not veer the sides. It did eventually break off as well because, again, the balsa is not super sturdy. So that was kind of the only con, is that one of my flights did have to go without it because it broke off. But yeah, and then kind of through this testing, I eventually landed on this final design that you see here, that I deemed probably had the highest probability of success. It's got an angled back wing, then angled down, really small angle, like 10 degrees at most, but enough to sort of counteract that lift force, make sure it didn't go straight up, stall, and just fall, because that happened a few times before I added it. And then the vertical stabilizer you can see as well. As for the sizing, I decided I just wanted the biggest aspect ratio I could get. So I made the main wing, the hypotenuse of this box, actually a little shorter so it could fit. But the hypotenuse of the box is 22.5 inches. I made the wingspan 21.5. And then the root cord and tip cord measurements are there as well. And then I found the area, because the area is a little, the taper doesn't go all the way quite to the middle. So that's how we get to that number there. Um, I think that this is pretty solid design overall. I also kind of whittled down the front of the glider as well, so it wasn't just a block flying straight forward. I felt that that was definitely helpful as well. It also helped the Play-Doh stay on better at the end. The center of gravity of this was right about at a third chord, so a little further back than I would have wanted, but overall was good enough to fly the 20 feet I needed. I think in the future, if possible, I would have made the front a little longer, so I could put the Play-Doh not all the way at the front, and then have that move that center of gravity up a little bit. But I couldn't quite get it right with the Play-Doh. I'd either overshoot or undershoot, so we ended up at about a third of chord on test day. Um, from there, we kind of just went with it. So here's my calculations for the aspect ratio. Um, yeah, and then here is me finding the angle. That line is level, and I just measured with a protractor. up to there, I found that angle to be about 6 degrees. So from there, we calculated my lift and drag coefficients. Lift was really straightforward. I just converted degrees into radians, 6 degrees and 6 pi over 180 radians to get that 0.68 or 0.658 number. And then drag was slightly more complicated. First, I had to find the like skin friction drag, as they call it, which is I kind of just looked up a reference to get that 0.004 value. And then the other assumption I had to make for the drag was the efficiency value, that E in that K equation, which I found from a lecture at Stanford online, based on thin airfoil theory and a couple other things. And we came to 0.727 to be my efficiency factor. And overall, that came out to, for the coefficient of drag, to 0.0168, which was pretty close to what other gliders on the internet that were similar to this got, as well as some of my peers. So I think my assumptions were fairly solid. Yeah. This is a picture, or not a picture, a video of my test flight, most successful test flight. Went 27 feet. Yeah. And then if it will let me, there we go. And then here is the bibliography of those two sources I used. And the first one I used kind of throughout the process of making this glider. I think my final design did meet the requirements. It flew 27 feet. It fit inside of the box. So overall, it was technically successful. However, I think I could have done significantly better. I think given another chance, I would use a dihedral. I think I saw a lot of people be really successful with that on test day. I think that's something I would do as well. But overall, I think a lot of my initial sort of ideas and assumptions were fairly solid and led to a glider that met the requirements and didn't do a whole lot more. But had the requirements changed, I think I would have adapted as well.